Okay, I've got sine squared 3x times cosine of 3x dx. Now, this is one that we should be able to kind of do without any new information today. What does your gut tell you that you think your u value should be? Sine. Yeah, specifically sine of 3x, right? So u is going to equal sine of 3x. And then I'm going to take the derivative of both sides. So du on the left is equal to, what's the derivative of sine of 3x going to give me? 3 cosine of 3x dx. Okay, I'm going to get that dx by itself. I'm going to divide by 3 cosine of 3x, and that's going to equal my dx. So now I can rewrite my integration problem. My u was equal to sine of 3x, so this is going to become u squared times cosine of 3x, and then my dx is actually equal to du over 3 cosine of 3x, so times du over 3 cosine of 3x. Okay, that cosine of 3x goes away. And I'm going to rewrite this integration with that 1/3 out in front. So this is going to be 1 divided by 3 times the integral of u squared du. Can we integrate u squared pretty easily? Yeah, we add 1 to the top and divide by that number on the bottom. So this becomes 1/3 u to the 3rd divided by 3 plus what? C. Okay, and I can go ahead and simplify this. This becomes 1/9 u to the 3rd plus c. And to finish out our problem, we do have to re-plug in our u value. So this becomes 1/9 times sine of 3x to the 3rd power plus c. Okay, again, if you were writing it with the 3 right here, that is fine. But if you are writing the 3 where I have it without parentheses around it, that would not be the same thing. So make sure either you put parentheses around the whole thing or you put the 3 in between the sine and the 3x. Okay, questions on that one? Okay, moving on to some U-substitution with exponential functions. Okay, we're going to do probably about 3 of these here. When we have exponentials, we're pretty much always going to let our u value be the exponent. Okay, for letter A here, I've got e to the 3x plus 1. So I'm going to let u equal my 3x plus 1. If I take the derivative of both sides, I end up with 3 dx. And if I get dx by itself, I get du divided by 3 is equal to dx. Okay, so I can rewrite my integral. I've got now the integral of e to the u power du divided by 3. Can I take that 1/3 out in front? Okay, so let's rewrite that as 1/3 integral of e to the u du. And what is the integral of e to the u? Just e to the u. So I've got 1/3 e to the u plus c. And my u value I've got to plug in is 3x plus 1. Okay, remind me again, how can I double check my answer to make sure that I'm correct? Anyone remember? Yeah, take the derivative. If I take the derivative of this piece right here, I would end up with the same thing, right? But then I would times it by what? 3, right? And then 3 divided by 3 is 1. So do I end up with the exact same thing that I had originally? Yeah. Okay, so you can always double check your work from your integration by taking the derivative of both sides. Okay. All right, let's look at letter B. I've got the integral of 5x times e to the negative x squared. Okay. What does our gut tell us that our u value should equal? Negative x squared. Okay. So u is equal to negative x squared. I'm going to let you guys go ahead and try this one out. I will show my work up here in a few minutes, but work with the people sitting next to you, and if you have questions, let me know. Okay, so are we all okay after I've plugged everything in so far with what I've got? And then I can go ahead and simplify my x's. Those go away. And I am just left with the integral with a 5 out front. The integral of e to the u. And then I'm actually going to also pull out that negative 2. And the integral of e to the u is just e to the u. So this becomes negative 5/2 e to the u plus c. And then if I plug my u value back in, I get negative 5/2 e to the negative x squared plus c. Any questions on that one? Okie dokes. We're going to skip D, and we are going to do letter C. Okay. Letter C. Would it make more sense for my u value to be 1 over x or my x squared? 1 over x. Okay. So if I let u equal 1 over x, I'm going to rewrite this as x to the negative 1 power. Just be a little easier for me to take the derivative of. So if I take the derivative of both sides, I would end up with negative x to the negative 2nd power times dx. Now if I get dx by itself and I divide by negative x to the negative 2nd power, that goes away, but then du over negative x to the negative 2nd power, is there a way that I could rewrite that? If it's negative in the bottom? Yeah, move it to the top, right? So this is the same thing as du times negative x squared. That's what is equal to my dx. So now I can plug in my information that I know. This is e to the u power over x squared times my dx, which is equal to this negative x squared du. And what's going to go away? Those x squareds are going to go away. I knew that's what it meant. And then I'd have the integral of e to the u du. Yes, I do have a negative. I'm going to bring that out front. Is that okay?
Yeah.
Okay. And then if I simplify this, this is just negative e to the u plus c, which means it's negative e to the 1 over x plus c. Okay, if you want to try out d at some point, you can. This is the answer that you should get. You should end up with negative e cosine of x plus c for that one. Okay. Now these next two are in the form of 1 over u. And if I take the integral of 1 over u, I end up with the natural log of u. Okay, specifically u in absolute value for this. Okay. So if I look at letter A, I've got 6x minus 2 in the numerator, and I've got 3x squared minus 2x in the denominator. So I could let my u be one of these two things. Which one would be the best option?
Presumably the bottom one.
The bottom one, yeah. And if you're not sure, you can always kind of double check, right? Like if I let u equal 6x minus 2 on the top, and I took the derivative of both sides, what's the derivative of the right side going to give me? Just 6. Is that going to help me get rid of any of those other variables? No. So it would be smarter to do the denominator is equal to my u value. So u is equal to 3x squared minus 2x. Which means if I take the derivative of both sides, I get 6x minus 2 dx, which is just so convenient because that whole thing is going to go away, right? I'm going to solve for my dx here. So dx is equal to du divided by 6x minus 2. And now I can plug that information into my integral. So 6x minus 2 over my u times du over 6x minus 2. Again, this isn't a step you necessarily have to show, kind of like you saw in the homework there, how you just kind of jumped to that next step. But I think it's kind of helpful to visualize what's going on, what goes away. And then this is going to equal the integral of 1 over u du. And the integral of 1 over u is just the natural log of u. So this becomes the natural log of the absolute value of u plus c, which is the natural log of 3x squared minus 2x plus c. Okay, if I look at letter B here, I've got secant squared x over tangent of x. So if I let the numerator or the denominator equal u, which one is going to allow me to cancel out one of those trig functions?
Secant squared of x?
If I let u equal secant squared of x, and I take the derivative of secant of x, secant squared of x, am I going to end up with?
Wait, no.
No, I don't think so, right? Because then I would technically have to do the chain rule, chain rule. I would do 2 times the secant of x times the derivative of secant of x. That's not going to help us.
Yeah, no, I think I'll need to go.
Yeah. So let's do the u value as equal to tangent of x. What is the derivative of tangent of x?
Secant squared of x?
It is secant squared of x. So I can get my dx by itself. And now I can replug in my stuff into my integral. So I've got the integral of secant squared of x divided by u times du over secant squared of x. So those go away. And again, we have 1 over u du. Well, 1 over u, the derivative of that would just be the natural log of u, and our u in this case is tangent of x. Okay, so we've got these inverse trig functions here, okay? These are our basic formulas. If I had the integral of basically 1 over the square root of 1 minus x squared, that should look familiar. That's my arcsine, followed by our other ones down below of arctan and arcsecant. On the right-hand side, this is what we're going to use for U-Subsitution, okay? Now, I will tell you in this class, if this is on a test, I will give you these formulas, but you have to know how to use them. On the AP test, I don't know for sure. I need to double check. I'm not sure if you have to have these memorized or if they give them to you as well, but I don't think they show up very often, okay? But we can use that formula to answer the derivatives. So if we look here, all of these have like a squared, that's too big, a squared and u squareds, right? I'm going to color code all my a squareds here to be red and all my u squareds here to be blue. Okay, so for U-Subsitution in this case, when you have something over and it looks like it's in the inverse trig functions format, you're not going to let u be the entire thing underneath the square root, okay? For letter A is similar or looks like which arc function up here? If I've got the square root of 4 minus x squared, that looks like the arcsine, right? So I need to find out what is my u squared equal to and what is my a squared equal to. We'll just look at where like they are placed, right? My u squared is equal to x squared and my a squared is equal to 4. So when we're solving our derivatives and things and our integrals, we've been doing u equals something, right? But in this case, my u squared is equal to x squared. So what would u equal if u squared equals x squared?
Plus or minus x?
We're just going to look at the positive, though. So yes, u is equal to x. And then I can take the derivative of both sides. So my du is equal to just dx. If I look at this formula over here, though, my formula is I need to figure out what my u value is and my a value is, and then it's just going to be the arcsine of those two values. So I know my u value. I need to find my a value. So if a squared is equal to 4, what is my a value going to equal? 2. Okay? And we don't need plus or minus here, just the 2. So now I'm going to use that formula up there. Okay? This is the arcsine of just my u over my a. So this is equal to arcsine of u, which is equal to x, divided by a, which is equal to 2, plus c. What trig function or inverse trig function does letter B look like? The arctangent, right? So I need to find what is my u squared or my u value, and then what is my a value. So if I let u equal, or u squared equal 9x squared, what would u equal? 3x. If I let a squared equal 2, what would a equal? The square root of 2. Okay. I didn't fully show this last one, but I do want to show this one out. So if I take the derivative of both sides, this is du is equal to 3 dx. And my du divided by 3 is equal to dx. So I'm going to rewrite this trig function here, this integral, in terms of my a squared and u squareds. So you guys kind of see where all this stuff kind of comes from here. So I've got the integral of my dx, which is actually du over 3, divided by my a squared, which is that 2. I'm just going to write a squared so we see where that comes from. And then my u squared, so plus u squared. So technically that 1/3 comes out in front. So I've got 1/3 times the integral of du over a squared plus u squared. Okay, now the difference between what we have here for this formula and what I have here is that this du was divided by 3. So I do have another number like out front here that I have to account for when I'm answering what the integral of this would be. So for this part, we can use my formula. So my formula is 1 over a. So I'm going to have my 1/3 still. But then I've got that times 1 over a, and my a value is the square root of 2. And then it's arctan. And then I've got u over a. So u over a would be 3x over the square root of 2 plus c. We could leave it like that. We could simplify the denominator to be 3 times the square root of 2 on the bottom there instead of 2 separate fractions. But this would be your final answer here. Okay, on the previous problem, I did not have anything in front of my arc sign because my du just equaled my dx, right? There was no dividing by anything for that one. Questions on that one? All right, last one we got to use is going to be my arcsecant function there, okay? So go ahead and find what is your u value and your a value for me. Do we agree with u being 2x and a being 3? Yeah. Okay, so now I'm going to go ahead and plug in all that information. Oh, we also need to take the derivative. So the derivative of this side is 2 dx. So my dx is actually du over 2. Okay, so if I plug all this information back into my integral, I've got the integral of du over 2 on the top. And then that's divided by, underneath my square root, I've got my u squared minus a squared.
What about the x outside?
That's a great question. What about the x outside? The x outside, if I look back up here, x is technically equal to u.
I can't be right though.
But we said that u is equal to 2x, right? So my x is actually going to be equal to what in terms of u?
You 1/2 u?
Yeah, u divided by 2. That's exactly right. Okay, because this is just like our generic formula, right? So these things have to be the same. So if my u value is 2x, this value is actually, we have to solve for what that x value is. So it's u over 2. Okay, so now do we see here I've got 1/2s on top and on bottom, so those can cancel out?
Yeah.
And now I've got back to that formula of integral of du on top over u times the square root of u squared minus a squared, where we have our u values and our a values. Now I can just take and plug that into my formula up top. So my answer is 1 over a, where a is 3, arcsecant of the absolute value of u, so absolute value of 2x, divided by a plus c. Okay, so now these next problems are like, if we let u equal something and then we end up with still 2 variables and we can't do anything else, we can actually solve for x, kind of like what we just did. We can solve for x in terms of u, okay? So that's what's kind of this change of variable method is what it's called. So if I look at example A, I've got the integral of x times the square root of 2x minus 1. So your gut probably is telling us that we should probably let u equal the stuff underneath the square root. Yes? Okay. So if I do that, if I let u equal 2x minus 1, and I take the derivative of both sides, I get 2 dx. If I solve for dx, I get du over 2. Okay, which is going to be an issue because is this x going to cancel out?
No.
No. So let's see what happens when I plug all this information back in. I've got the integral of x times the square root of u times du over 2. I cannot integrate this yet. Okay, but do I have an equation that has u and x in it?
Yeah.
Yes. Could I solve this equation for x? I can. So let's go ahead and solve this equation for x. When I do that, I get u plus 1 divided by 2 is equal to x, right? And now I'm going to replace that for my x value. So I'm going to plug in this u plus 1 over 2 for x. And I get the integral of u plus 1 over 2 times the square root of u du. And I've technically got that 1/2. Can I bring that 1/2 out here? Yeah. All right. So I'm going to move this also 1/2 out in front. So this is actually going to be 1/4 out in front times the integral of, I've got u plus 1. And then I'm going to rewrite the square root of u to be u to the 1/2 power. Okay, now this problem brings us back to day 1 of integration, because what I can do now is I can just distribute this, and then I'm going to have 2 separate integrals that I can integrate and just add them together. Okay, so this now becomes 1/4 the integral of u to the 3/2 power plus u to the 1/2 power. Do we agree? Okay, and now can we integrate both of those pieces individually? Yeah, go ahead and try that. Leave your 1/4 out in front because it does have to distribute to everything. So go ahead and take the integral of u to the 3/2, and then u to the 1/2. Okay, that's what oh, my bad, I made a mistake. That should be a 3. And that should be a 2/3. Do we agree with how I rewrote those fractions? I mean, technically, if you had u to the 5/2 and then divide by 5/2, that's the same thing. I just rewrote it so that it was multiplying by the reciprocal. And then if I simplify my final answer, I'm going to simplify the fractions and then plug in my u value. Okay. So now I'm going to distribute that 1/4 to the 2/5, which simplifies to give me 2/20, which is 1/10. So I've got 1/10 u to the 5/2 power plus my 1/4 times 2/3. That's going to give me what as a simplified fraction? 1/6 u to the 3/2 plus c. And I'm pretty sure I just said I was going to replace the u as well, but I forgot to. So I'm going to replace the u now by plugging in my u value of 2x minus 1. And that right there is your final answer. Let's do letter B. I've got the integral of 2x plus 1 over the square root of x plus 4. So again, if you've got stuff underneath the square root, that's usually where your u is going to be. Or if it's going to be raised to a power, that's where your u is going to be as well. So my u value is equal to x plus 4, which means if I take the derivative of both sides, I get du is equal to dx. So if I plug in this information, I get the integral of 2x plus 1 over the square root of u du, sorry. Okay, now can I do anything with that right now? No, I've got to go and solve for x so that I can plug in something for x in terms of u. So let's solve for u up here, or sorry, for x. To solve for x, I get u minus 4 is equal to x. So now I can take this and I can plug that in for x so that I have just one fraction in terms of u, and then I can actually integrate this. So this becomes the integral of 2 times u minus 4 plus 1 over the square root of u. Okay, let's simplify this again. I've got the integral of 2u, and then that'd be minus 8, but plus 1. So that'd be minus 7. Are we okay with that?
Yeah.
And then are we okay if I also move that u to the negative 1/2 up to the top? And now from here we can go ahead and distribute. And this becomes the integral of 2u to the 1/2 power minus 7u to the negative 1/2 power du. And now from here, can we integrate this? Yeah, go ahead and try integrating this real quick, and we'll see what we get. We should have gotten 2u to the 3/2 divided by 3/2 minus 7u to the 1/2 divided by 1/2 plus c. And I can rewrite that and plug in my u values. So this becomes 2 times 2/3, where u is x plus 4 to the 3/2 power, minus 7 times 2, moving that reciprocal up, times x plus 4 to the 1/2, and plus c. I can simplify that one more time, but I don't really want to rewrite the whole thing. But if you got 4/3 and then 14, that would be ideal. But this is your final answer. Okay, we are not going to do B, so you can cross out letter B. What I am instead going to do is I'm going to show you how to solve letter A with both approaches. I'm going to start with the one that I don't love as much, and then I will end with the one that I prefer you guys use, but either one is fine technically, okay? So the only difference for these is now we have actual bounds. We have 0 and 1 there. So we actually are going to get a number answer out at the end. Okay, but we first got to do some U substitution. What are we going to let U equal in this case? X squared plus 1. That's exactly right. So U is equal to x squared plus 1. So my derivative is 2x. And then I've got du over 2x is equal to dx. Okay, so I can go ahead and plug in this information. I've got the integral of x times u to the third du over 2x. Okay, now in this case, we don't need to solve u in terms of x because our x's are going to go away, right? Our x's are gone. And now I just have the integral of u to the third power times du. I'm going to move that 1/2 out in front, if we're okay with that. Now you'll notice I did not write the 1 and the 0 there. That's because I'm going to call this kind of method the no bounds method, because these bounds are in terms of x, because this function is in terms of x, right? But x is not equal to u, right? X squared plus 1 is equal to u. So we're going to evaluate this integral first, and then change everything back in terms of x, and then evaluate it at 1 and 0. So if I take the integral of u to the third, I end up with u to the fourth power over 4. But then I'm going to plug in, and technically I have my plus c, but I'm going to plug in my x squared plus 1 for u. So I've got x squared plus 1 to the fourth power divided by 8.
No C?
Okay, no c, because right now we're going to evaluate it at 1 and at 0. So I'm going to evaluate this at 1 and at 0. Okay, so that means I plug in 1. When I plug in 1 to this function, I'm going to write it above here, I get 2 to the fourth power, which is 16, right? And then 16 divided by 8 gives me 2. We okay with that math there? If I plug in 0, I'm going to get 0 plus 1 raised to the fourth power divided by 8. And that gives me 1/8. Oops, I don't know why I put a plus sign there. We're supposed to subtract those things. Okay, if I subtract those two things, common denominators would be 8. So this would be 16/8 minus 1/8, which gives me 15/8. Okay, so when we solved it using this method, we integrated it pretending like there were no bounds, and then once I solved and plugged back in my x value, I can evaluate it at 1 and at 0. Okay. Now, the other method is where we change the bounds. Okay, so let's see, change the bounds to be in terms of u. Okay, so I'm going to go and rewrite this function right here. I have the exact same function because I'm going to do the exact same problem. So this would be 1/3 times the integral of u to the third du. But what I'm going to do is I'm going to change the 0 and the 1 to be in terms of x. Or sorry, in terms of u. So if this is x, if x is equal to 0, and I plug that in here, what is u going to equal? 1, right? So if I plug that in, I get that u is equal to 1. If I plugged in 1 for x, I get 1 squared plus 1, so that would mean u is equal to 2. Okay, so if I find the new bounds in terms of u, then I can just evaluate my function without plugging back in my x squared plus 1 for u. Okay, so I'm going to rewrite these bounds here. These are going to be 1 and 2.
Wait, why did you put 1/3?
Was it not 1/3? What was it?
1/2?
Oh, sorry, it's 1/2. I can't read my own handwriting. Thank you, thank you. And now I can integrate this. Okay, so when I take the integral of u to the third, I still have that 1/2 in front, but I'm going to have u to the 4th power over 4, and then I'm going to evaluate that at 2 and 1. But let's just simplify this one more time to be u to the 4th over 8, and I'm evaluating it at 2 and at 1. Okay, we should get the exact same answer. We just, instead of plugging back in my x squared plus 1 for u, I changed my bounds. So when I evaluate this, this becomes 2 to the 4th power over 6 or over 8, which is still 2. And then if I plug in 1, I have 1 over 8. So 2 minus 1 over 8, that also equals 15 over 8. Okay? Do you see how you get the same answer there but 2 different ways? Okay? Again, either way is fine, just as long as you are consistent and careful with either changing your bounds or plugging your stuff back in before you evaluate it. Okay? Example 10 here is as an example of what a multiple choice kind of question could look like for this. If you're given an integral and it says the substitution must be that u is equal to x over 2, how would I simplify this integral in terms of u? So, if I would plug in u here, this is technically the integral of 1 minus u squared over, well, I can't have two variables, right? So how could I solve for x? What would x equal if this is my equation? 2u, right? So x is equal to 2u, so I can write 2u here. Now I do need to solve for dx. I get dx by taking the derivative of this formula right here. So if I take the derivative of both sides, I get du is equal to 1/2 dx. And again, I just want dx. So to get dx by itself, I multiply by 2. So 2 du is equal to dx. Does that make sense what I just did there? Okay, so my 2 du is going to replace my dx. And now what's going to simplify on the top and the bottom there? Those 2's go away. And now if I look at my 4 options here, A, B, C, and D, which 2 can I get rid of right away just based on what I have after my integration symbol? A and C. I can get rid of A and C right now. Now the only difference between B and D is what? The bounds, right? So the bounds for B are 4 and 2. But are those the bounds for U or are those the bounds for X? Those are the bounds for X because this is in terms of X. So if I want to know what the bounds for U are, I have to plug in the bounds for X into my formula. So if I wanted to find out what they are, if X is 2, what is 2 divided by 2 going to give me? 1. So my U for this one is equal to 1. If I plug in 4, 4 divided by 2 is 2. So U is equal to 2. So my answer is letter D for this one. Okay, if the bounds don't match, you're not going to get the right answer, right? The bounds have to match for the variable that you're evaluating it at. Okay, last problem here, and then you guys will have the rest of class to work on whatever you need to get ready for your quiz. This one, worded kind of weird, and now we have a table, but you do have all the information you need to answer this, okay? But this is kind of one of those like AP style questions. So if I look here, we're given twice differentiable, sorry. And we're given a table of values here. So if I look at this function, I've got g prime of f of x times the derivative of x. So this piece right here on the inside, if you think about this in terms of U-substitution, wouldn't that be the same thing as like saying I'm going to take and plug f of x into my function g of x? Right? So it's kind of like my u value. This f of x is u. That's what I'm plugging in terms or in place of f of x. And if I took the derivative of both sides, what would I get on the right-hand side? Derivative of f of x would just be f prime of x times dx. Now this piece right here is in that formula, right? So I could think about this instead of in terms of u. I've got the integral of g prime of u times du based on what I just plugged in there. Do we agree so far? Okay. Now, these bounds are in terms of what? In terms of x. But I'm now in terms of u. Okay? So I need to change my bounds to also be in terms of u. So if I know that u is equal to f of x, this would be equal to, for u, is f of 0. Well, what is f of 0? Let's use our table. F of 0 is 1. If I plug in 5 for my function for u, I get f of 5, and f of 5 is 3. So my new bounds are going to be from 1 to 3. Because now they are in terms of u, which is what my integration is in terms of. Okay. If I integrate the first derivative, what do I end up with? If I integrate the first derivative, I get out my g of x function. Okay? If I integrate my second derivative, I end up with my first derivative, right? It's going backwards. Like if I was taking derivatives going forward, I would just keep adding that little tick mark. If we're taking integration or antiderivatives, we're going backwards. So this is actually equal to g of 3 minus g of 1. And then from here, we just gotta take our values from our function, or from our table. So what is g of 3? 3, and then just some simple math here. So I've got 3 minus g of 1, which is, oh, not 14, but 10. 3 minus 10, negative 7. All that work for negative 7. You guys are so smart.